Welcome. Don't forget to subscribe, like, and enjoy. Imagine staring into the abyss of deep space, where darkness stretches endlessly, broken only by the distant glow of dying stars. But somewhere, hidden within this void, a cataclysmic event is unfolding, one so rare and powerful that it could shake the very fabric of the universe. Two supermassive black holes, each millions of times the mass of our sun, are locked in a gravitational dance, spiraling closer and closer. Their inevitable collision will unleash more energy than 1 billion supernovae, sending ripples through space and time itself. For the first time in history, astronomers have detected a pair of these cosmic titans on the brink of merging. The discovery has sent shockwaves through the scientific community. If what they predict is true, we are on the verge of witnessing one of the most violent events in the cosmos, a moment so powerful it will bend the very structure of reality. But what will happen when these two giants collide? Could their immense gravitational forces trigger something we don't yet understand? And most importantly, could we feel the impact from Earth? For centuries, black holes were nothing more than theoretical monsters, predicted by Einstein's equations but never seen. These cosmic voids devour everything in their path, warping space and time with an invisible force so strong that not even light can escape. But while individual black holes are terrifying enough, what happens when two of them collide? Until now, it was a question without a real answer. Then, astronomers spotted something extraordinary. Using some of the most powerful telescopes on Earth and in space, like the Event Horizon Telescope and NASA's Chandra X-ray Observatory, scientists detected a faint but unmistakable signal. The gravitational echoes of two enormous black holes locked in an unstoppable spiral toward one another. Located in a distant galaxy, billions of light years away, these supermassive black holes had likely been orbiting each other for millions of years, drawing closer with each passing moment. This isn't just another black hole sighting, it's a first-of-its-kind discovery, a direct confirmation of something astrophysicists have only theorized about. While black hole mergers have been detected before, they've always been between much smaller stellar mass black holes. This, however, is something else entirely. These giants are millions of times heavier than our sun, residing at the hearts of two merging galaxies. Their collision will be so immense that it will send gravitational waves rippling across the universe, disturbances in space-time that we might even detect here on Earth. But what led to this moment? And how do we know for sure that the collision is imminent? The clues lie in the light signals coming from their chaotic surroundings. But here's where things get even more bizarre. Scientists weren't even looking for this when they found it. The discovery came as a surprise while astronomers were studying distant quasars, the hyperactive centers of galaxies powered by supermassive black holes. Instead of observing a single, stable light source, they noticed something unusual, a flickering pattern like a cosmic heartbeat. This irregular pulsing suggested that something massive was moving, two enormous black holes orbiting each other in a slow but inevitable spiral toward collision. To understand what's happening, imagine two whirlpools forming in the ocean. As they grow larger, their swirling currents pull them closer together until eventually they merge into one massive vortex. That's exactly what's happening here, but instead of water, these black holes are warping space-time itself. Their immense gravitational pull distorts everything around them, dragging nearby stars and entire clouds of gas into a violent gravitational tug-of-war. This isn't the first time we've detected black hole mergers. In 2015, scientists at LIGO, Laser Interferometer Gravitational Wave Observatory, made history by detecting gravitational waves from two colliding stellar mass black holes, proving Einstein's predictions from a century earlier. But those black holes were tiny compared to the ones we're seeing now, only a few dozen times the mass of the sun. The ones currently on a collision course, millions of times heavier. This changes everything. When these two supermassive black holes finally collide, the energy released will be so extreme that it could briefly outshine every star in their entire galaxy combined. The impact will send gravitational waves surging across the universe, distorting space itself like ripples on the surface of a pond. And here's the truly mind-bending part. those ripples will eventually reach us. Scientists on Earth will be able to detect the aftershocks of this cosmic event, proving once again that black holes aren't just mysterious voids, but some of the most powerful forces shaping the universe. But what happens in the final moments before the collision? What would we see if we could get close enough? The answer is even more terrifying than you might expect. If these two supermassive black holes continue on their current trajectory, the results will be nothing short of catastrophic, for their host galaxy at least. As they spiral closer, the surrounding space becomes a maelstrom of destruction. Entire stars will be flung out of orbit, sent hurtling into the void at unimaginable speeds. Gas and dust trapped between them will be heated to millions of degrees, igniting in a final, desperate blaze of energy before vanishing into the abyss. Then, in one final, apocalyptic moment, the black holes will collide, merging into a single, even more monstrous entity. The sheer force of this impact will unleash a shockwave so powerful it will ripple across the universe for billions of years. But here's where things get even more shocking. Some scientists believe that such an event could trigger something we've never seen before. The gravitational waves released will be the strongest ever detected, shaking the very fabric of reality. There's even speculation that the merger could briefly create something known as a superkick, where the newly formed black hole is violently ejected from its galaxy at speeds nearing 1/10 of the speed of light. Imagine that, an object billions of times heavier than our sun, flung into intergalactic space like a cosmic bullet. And then comes the real question: could an event like this ever happen closer to home? Some scientists argue that our own Milky Way may one day face a similar fate. At its heart lies Sagittarius A, a supermassive black hole, quietly lurking. But millions of light years away, Andromeda, our neighboring galaxy, is on a collision course with the Milky Way. When the two galaxies merge, could their black holes meet the same fate? Could our sky one day be filled with the light of a similar cosmic battle? If that sounds like the end of the world, well, don't panic just yet. The collision of Andromeda and the Milky Way is still billions of years away. But this event, happening right now in a distant galaxy, is a glimpse into our own cosmic future, and it leaves us with one final haunting question. What other forces are lurking in the darkness, waiting to reshape the universe as we know it? This collision is more than just a rare cosmic event. It's a window into the deepest mysteries of the universe. The gravitational waves it sends rippling through space-time will give scientists an unprecedented opportunity to study black holes, unlocking secrets hidden for billions of years. By analyzing these signals, researchers may finally answer some of the biggest questions in astrophysics. How do black holes grow? What role do they play in shaping galaxies? And could these mergers be responsible for some of the most extreme cosmic phenomena we've yet to understand? But beyond the science, this event forces us to confront an even greater reality. The universe is constantly changing, evolving in ways both beautiful and violent. If supermassive black hole collisions are happening right now, in galaxies billions of light years away, how many others have already reshaped the cosmos? Could they even influence the formation of habitable worlds or the fate of extraterrestrial civilizations? Scientists are already preparing for the next step. New space telescopes like the European Space Agency's LISA, Laser Interferometer Space Antenna, will soon allow us to detect gravitational waves with even greater precision, painting an even clearer picture of these colossal mergers. One day, we may not just observe these events, we may predict them before they happen, unlocking a new way to explore the darkest corners of the universe. This is just one piece of a much bigger mystery. Every discovery, every collision, every signal from deep space brings us closer to answering a fundamental question. What is the ultimate fate of the universe? Because if black holes can merge, if galaxies can collide, then what will happen when the universe itself reaches its final moments? The answer could redefine everything we think we know about space. The collision of two supermassive black holes is one of the most violent and awe-inspiring events in the universe. It confirms what scientists have long suspected, that the cosmos is far from static. It is alive, constantly shifting, with forces beyond our comprehension shaping its future. This event will send shockwaves across space and time, rewriting what we know about black holes, gravitational waves, and even the structure of reality itself. But if this can happen in a distant galaxy, what else is waiting to be discovered? Could black hole mergers be far more common than we realize? And if so, what does that mean for the ultimate fate of the universe? Could these collisions one day determine how everything, galaxies, stars, even space-time itself, will come to an end? We are only scratching the surface of what the universe is hiding. What do you think? Could this discovery change our understanding of space forever? Let us know in the comments, and don't forget to subscribe for more deep space mysteries. The universe is full of secrets, and together we're just beginning to uncover them.